Let's imagine you took any old circle and inscribed an equilateral triangle. Well, you're using 3 chords to do it. What is the probability that a randomly chosen chord is longer than any of these 3? So if I just picked a randomly chosen chord, what's the probability that pick is longer than one of those? Well, you might be able to convince yourself that any radius of this circle is half inside and half outside that equilateral triangle. So if you made a circle like that, imagine that the radius of the inside circle is 1. That means pi 1 squared, the inside area is pi. The outside one has radius 2, pi 2 squared. The area is 4 pi. So the inside circle has 1/4 the area of the outside circle. So now I want to look at that nice little line and look at the midpoint of that line. Now I want you to notice something. When is the midpoint of that line inside the circle? Well, here the chord is shorter in length. Right there it's equal in length. There it's longer in length than your equilateral triangle. So when the chord is outside, that's 3/4 of the area, it's shorter, but 1/4 of the time the midpoint of the chord is inside the smaller circle, and so the chord is longer. So 1/4 of the time the chord is longer than the sides of this equilateral triangle. 1/4. Isn't that great? That's right, I think.